Alright, in this video I'm going to be covering section 6.4 where we're going to discuss adding and subtracting and more multiplication with radicals. So adding, subtracting, and also we're going to do more with multiplication with radicals. So first of all, let's look at how we add, or I should say adding and subtracting radicals. So first of all, I want to say we can only add or subtract what we call like radicals. Like radicals. Like radicals have the same root and the same radicand. Remember, the root would be like a square root or cube root. The radicand is just the number under the radical, the number under the radical symbol. Alright, so let's look at some examples of like radicals and some unlike radicals. So first of all, for like radicals, square root of 3 and 5 square root of 3. These are like radicals because they're both square roots and they both have the same number under the radical, which would be 3 in this case. Another example would be 2 square roots of x and negative 7 square roots of x. One last example would be 4 cube roots of 6 and 7 cube roots of 6. So in each case we have the same root, like here they're both cube roots, and also the same radicand. The number under the radical is the same. Now some unlike radicals would be like square root of 2 and square root of 5. Notice they don't have the same radicand or number under the radical symbol. So one thing I want you to notice is when we multiply, we just multiplied the 2 and 5 here. Square root of 2 times square root of 5 is square root of 10. So we talked about how with multiplication you can multiply this way as long as your roots are the same. Notice with addition, it's more than that. Not only do the roots have to be the same, but the radicands have to be the same. Let's look at 2 more examples of some radicals that are not like radicals. How about the square root of 6 and the cube root of 6? Of course, they don't have the same root. Or the square root of 3x and the square root of 5x. Now those are tempting to think that they might be like radicals, but remember they have to have exactly the same number under the radicand, and they don't. Alright, next thing I want to say is we add and subtract like radicals like we do with like terms. So for example, if you have 2x plus 3x, you get 5x. So all we're doing is adding the coefficients. In this case, it's just the number that's out front of the radical. So here would be a 1 and a 5 here. If you wanted to add these two together, 1 plus 5 would give you 6 square roots of 3. Alright, so let's go ahead and practice. It says add or subtract if possible. should say our problem, our question is to add or subtract. Number 1, 4 square roots of 3 plus 7 square roots of 3. Well, they're like radicals, so all we have to do is add the 4 and the 7 together. We get 11 square roots of 3. Now keep in mind, this really means 11 times the square root of 3, or we can say 11 square roots of 3. And I probably should put that 11 just a little bit closer than I did. Number 2, the square root of 5 minus 3 square roots of 5. And actually, I'm going to give you 2 more. Number 3, 2 cube roots of x plus 8 cube roots of x. Number 4, 2 square root of 3 plus 3 square roots of 2. So go ahead and try those and then watch the video. Sorry about that. Let me fix that. I'm going to send a text here so they know that I'm in the middle of making a video. Okay, let's continue on. So first of all here, remember this is 1 square root of 5 and a minus 3 square roots of 5. Of course 1 and negative 3 is negative 2. So we have negative 2 square roots of 5. These are both like radicals because they're both cube roots with the same radicand x. So 2 and 8, we get 10 cube roots of x. Now, if you look at number 4, neither of these are like radicals. And so we would just say this one is already simplified. Let's do one more here. So 2 plus 4 square roots of 3. So I want you to look at that, maybe think about what the answer should be, and then watch the video. All right, well this is just a number, and this is a radical. Now remember, we could only add 4 square roots of 3 with another radical 3, like 2 square roots of 3. So in this case, this is not even a radical. We can't add the 2 and the 6, or 2 and the 4, because the 4 is connected to the square root of 3. So this is a radical term, this is not. So there's nothing we can do here. This is also simplified. All right, let's move on to number 6. 3 square roots of 50 minus 4 square roots of 2. Now at first glance there, you might think that this does, I'm going to go ahead and focus in. It seems like my camera's a little off focus. But anyway, it looks like these are not like radicals, but notice the 50 here. This is not a radical that's simplified. In fact, 3 times the square root of 50 is 3 times the square root of 25 times the square root of 2. 25 is a perfect square factor of 50, so we want to break this down into the square root of 25 times 2. Well, this is 3 times 5 times square root of 2. This is all multiplication, and so we get 15 square roots of 2. So 15 square roots of 2 minus 4 square roots of 2. Now you can see that they are like radicals now that the left one is simplified. And so what's that, 11 square roots of 2? All right, why don't you try this one here. 12 square roots of 45 minus 8 square roots of 80. Now I would recommend that maybe you simplify each of the radicals over here and then plug in the information. It'll make this a little bit more cleaner looking. So go ahead and try that one. All right, let's see how you did. So first of all, we have 12 square roots of 45, and of course if you look at our perfect square factors other than 1, you can see that 9 is a perfect square factor. So we have 12 times the square root of 9. Of course 9 times 5 is 45, so this will be square root of 9 times square root of 5. So this is 12 times 3 square roots of 5, or 36 square roots of 5. For the 8 square root of 80, now be careful here because 4 is certainly a factor, but if you break this into 4 times 20, 20 has a perfect square factor of 4 as well. So we need to go bigger, and notice 16 goes into 80. It's a perfect square factor of 80. It's 16 times 5. So 8 times the square root of 16 times the square root of 5. Again, 16 times 5 is 80, so that makes this work. And we know if we multiply these together, we do get square root of 80. But the square root of 16 is 4, so this is 8 times 4 times the square root of 5, or 32 square roots of 5. So this will be minus 32 square roots of 5, and 12 square root of 45 was 36 square roots of 5. And so if you subtract those, you get 4 square roots of 5. Now you could show this work in here, and the same thing with the other one here, if you prefer, but this is the way I like to do it. Either way is fine. Let's go ahead and move on to the next page. Let's see, I think we'll do one more of those. Actually, I think we're good. Let's go ahead and go on to multiplication. We said we were going to do more with multiplication. Okay, so number 1, square root of 3 times square root of 5. Of course, that's the square root of 15. We learned that that's how we multiply two radicals, as long as they have the same root. Now, be careful with this next one. The square root of 6 times the square root of 6. All right, so you should get 6 out of that. Now, if you multiply square root of 6 times square root of 6, of course, that's the square root of 36, but the square root of 36 is 6. But what we've learned is if you square a square root, squaring and taking a square root are opposites. So you take the square root of 6, and then you do the opposite thing and square what you get, you'll get back to the 6 you started with. So square root of 6 times square root of 6 is 6. Square root of 5 times square root of 5 will be 5. Square root of x times square root of x will be x. No matter what you put in here, if they're both the same, you're going to get the number back. All right, number 3. So we're progressively going to get a little more challenging here. So we have 6 square root of 6 times the square root of 5. Now in each case here, you may want to try these first and then watch the video. Now this is 6 times the square root of 6, and we're multiplying that times the square root of 5. But really all we have is multiplication going on here. Now I can multiply a radical times a radical as long as they're both the same root, but I can't do anything with the 6. I could multiply a 6 times a 3, but I can't do anything with, I can't do any further multiplication when I'm multiplying times these two radicals. So what I would do here is multiply the radicals together, and you get the square root of 30, and then that 6 just stays out front. All right, let's move on to number 4. 6 square roots of 6 times 3 square roots of 6. And I'm going to give you the other two if you want to try these. 2 square roots of 6 times 3 square roots of 5. And number 6, the square root of 3 times negative 4 square roots of 3. All right, so again, things are getting progressively more challenging. Let's see what you can do with those, and then watch the video. All right, so now, again, this is all multiplication. It looks like, we have a radical expression times a radical expression, but this is 6 times the square root of 6, and this is 3 times the square root of 6. So what I'm going to do, since I'm multiplying 4 numbers, I know I can multiply in whatever order I want. let's put the numbers together and the radicals together. Now we know that the square, 6 times 3 is 18. We also know that the square root of 6 times the square root of 6 is 6. And so we're going to multiply 18 times 6, and so we get 108. All right, on number 5, notice we can multiply the 2 and the 3 together. That's 6. And square root of 6 times square root of 5 is square root of 30. All right. On number 6, we can multiply the square root of 3 and the square root of 3 together. That's 3. So basically, we're going to get negative 4 times 3. So these two multiply together, and then you get 3, and then that's multiplied times the negative 4. So we're going to get negative 12 here. All right. So let's move on to number 7. So this is something that's going to look kind of familiar. Square root of 6 times 2 plus the square root of 6. So we're going to want to use the distributive property here. Of course, square root of 6 times 2, I can only multiply a square root of 6 times another square root. So all I can do is put this 2 out front. So when I multiply those two together, I can't say like that's the square root of 12. The problem is this is not a radical. Remember, you can only multiply a square root times another square root. Now when we multiply square root of 6 times square root of 6, that's 6. And so we get 2 square roots of 6 plus 6. All right, let's move on to number 8. Square root of 2 times the square root of 5 minus the square root of 2. Number 9, the square root of 2 times negative 5 square roots of 2 minus 7. And finally, number 10, the square root of 2 times 3 square roots of 10 minus 2 square roots of 2. All right, so see what you can do with those. Whoops, I'm sorry, I'm off the grid here. All right, let's see how you did. So when you multiply square root of 2 times square root of 5, you get square root of 10. Remember, a square root times a square root, you're going to get a square root of the two numbers multiplied. And we've talked about this. Now this is a positive times a negative, so it's going to be minus, and the square root of 2 times the square root of 2 is 2. All right, square root of 2 times negative 5 square roots of 2. In that case, square root of 2 times square root of 2 is 2, and you're going to multiply that by negative 5. So 2 times negative 5, and then the square root of 2 times a minus 7 is just going to be minus 7 square roots of 2. So we're going to end up with negative 10 minus 7 square roots of 2. Now for some people it helps, with this first multiplication you could have done this off to the side. Again, you can multiply these three numbers together, but only the like things can be multiplied together. So the square root of 2 times square root of 2 is 2, and then you still have that times the negative 5 that's there, and that's where we're getting the negative 10 from. All right, let's look at number 10. So here when you multiply the 3, we can't do anything with that, but we can multiply the square root of 2 times the square root of 10, and we get the square root of 20. And then the square root of 2 times minus 2 square roots of 2. So we're going to have a minus, because it's a positive times a negative. Now the square root of 2's can be multiplied together, and you get 2. But don't forget you also have this other 2. And so you're going to end up with 3 square roots of 20 minus 4. Now hopefully you notice there's one more thing here. And that is the 20 here, the radicand, this radical is not considered simplified because 20 has a perfect square factor of 4. And so we would want to break this down into the square root of 4 times the square root of 5 minus 4. And this is 2. square root of 4 is 2, times 3, we're going to get 6 square roots of 5 minus 4. Alright, and that's going to be it for this lesson. That's all, folks.